This is example 7.2. Example 7.2 reads, two brothers sit on a seesaw that is level with the ground. The older brother weighs 400 newtons and sits on the left side, 2.1 meters from the fulcrum. The younger brother weighs 300 newtons and sits on the right side, 2.4 meters from the fulcrum. A. Which direction is the angular acceleration, clockwise or counterclockwise? B. If the magnitude of the angular acceleration is 0.6 radians over seconds squared, what is the collective moment of inertia of the seesaw and the brothers about the fulcrum? For this problem, let's first draw the seesaw. Place the fulcrum in the middle. We know that we have one brother exerting a force of 400 newtons, 2.1 meters away from the fulcrum. We know we have another brother sitting on the right side, applying a force of 300 newtons downward, and that is 2.4 meters from the fulcrum. So we want to find the overall moment of this seesaw. We know that the brother on the left is exerting a counterclockwise force because it's pushing down from the left of the fulcrum, which would follow through and cause a counterclockwise motion. The brother on the right is applying a clockwise force, which would cause a clockwise movement of the seesaw. So to find out which of these moments is larger, we're going to use an equation we know, which is the force times distance equals the moment. So we'll write that out. So for the left brother, we know that he is exerting a 400 newton force, and it's 2.1 meters from the fulcrum. We find the answer to be 840 newton meters. This is the counterclockwise force. Now let's solve for the moment of the brother on the right. He is exerting a 300 newton force at a farther distance of 2.4 meters. We'll plug this into the calculator. We find that he exerts a moment of 720 newton meters in the clockwise direction. We can find the net moment by subtracting our counterclockwise moment from our clockwise moment. This gives us 120 newton meters in the counterclockwise direction because the counterclockwise moment was larger than the clockwise moment. This is how we know that our angular acceleration will move in the counterclockwise direction. Let's move on to B. B wants to know the moment of inertia if the angular acceleration is 0.6 radians over seconds squared. So let's write out everything we know right now. Our overall moment is what we just found, 120 newton meters in the counterclockwise direction. The problem gives us the angular acceleration, which is 0.6 radians per second squared. This is equal to 0.6 radians second to the negative 2. These are equivalent. And we are looking for the moment of inertia. We know an equation that includes all three of these things and will provide us a way to solve for the moment of inertia. This is moment equals moment of inertia times angular acceleration. Our moment is 120 newton meters, which equals moment of inertia times 0.6 radians per second squared. We will divide both sides by 0.6 radians per second squared. We will plug this into our calculator. Our moment of inertia is 200 kilograms times meters squared. This is the answer to part B. This is example 7.2.